Welcome back, everybody. This is week 3 of algorithmic filmmaking. I'm going to try to keep the lecture part of this short because there's a ton of material in the tutorial section. So hopefully let's dig right in and get into it. As a reminder, here's where we are this week. So last week we looked at visual analysis tools. This week we're going to look at what is probably more like content analysis tools and about content detection. And then next week we're going to look at doing more body detection and motion capture, that sort of thing. So a couple class updates. So I know I've been sort of asking people to update or upload their video data sets to the class folder. I think it probably makes more sense to actually hold off on that until maybe next week or the week after. In part just because there's a ton of data to process through, and uploading all your data sets every week is kind of annoying and it's slow. I think I have an idea on how to do a faster process for that. I'll look into it this week and then hopefully have updates on that for next week. Next, I am probably going to have to push class a week during what is U.S. Labor Day. That's week 5. So week 5 I think is supposed to be September 4th. September 4th is a holiday here in the U.S. and I'm actually out most of that week. So I will probably push it out till the following week. So it'll be September 11th when we do the week 5 materials. I'll post this in the Slack channel and see if anyone has any major concerns about that. I kind of have the sense that people are already a little bit overwhelmed with the amount of material we're covering every week. So I guess if it were my guess, I'm guessing that people would be fine with a week off to sort of catch up and take a breather. So I'll make that announcement in Slack just once I have a handle on it, and then let everybody know. Next, there was a bug in last week's Dimensions notebook. Thanks for Mary for helping me figure that out together, and I'm working on a fix for it. Hopefully I have it in the next day or two by the time you watch this. So I am working on that. It's a weird issue where I need an FL statement to capture where the min size, when you scale down to it, might actually break the ratio, other things like that. So I'll leave an update in that and hopefully fix that next day or two. Okay, this week we are looking at content analysis tools. So last week we looked at sort of the structure of things through edits, through dimensions, color, shot type. This week, I think we need to dive in and figure out what's actually in the image, right? Describe what's actually happening in the clip we're looking at. So we'll look at some tools that allow us to figure out what is in the video, both from an object perspective, but also in describing the scene. So a couple inspirational pieces for folks to watch this week. I made this thing called Deathbed as a part of the Scream Scenes project. And what it is a collection of all the scenes of people being afraid in bed, and a common trope of horror films is waking up from a nightmare and jumping out of bed. So this is sort of a hand curated collection of this, and this is actually done by hand. I went through all the clips we had and sort of pulled out the ones of someone laying in bed and sort of waking up and or just sort of realizing in bed something was scary was going on, that sort of thing. So that's one thing you can watch, just sort of keep it to look at it. And I sort of tried to sequence it so that everything was sort of in sequence from someone getting out of bed, laying down, getting up, and moving out of bed. That was sort of the idea behind that. Next is a piece called Film Ist. It's by an Austrian filmmaker by the name of Gustav Deutsch. I highly recommend watching this one. This is really cool. And if you're ever looking for experimental film that usually involves found footage that hasn't been destroyed or anything, the Austrians are really, really good at that. There's actually a second part of this. This is actually Film Ist parts 1 through 6, and there's another section that Gustav Deutsch made called 6 through 12, 7 through 12. And 1 through 6 is all old science education films that he's then edited together and sequenced in a way that I think is kind of capturing content as it goes, pieces one by one are kind of connecting together, which I find really, really fascinating. So we've got a bunch of these pieces of people sort of moving. There are these scenes of why is this not playing through that quickly? Anyway, I just think it's really great. It's an hour long, so it can definitely be a lot sitting at home trying to watch this. You're gonna wanting to pull out your phone, but just a bunch of buttons, right? And as you push the button, then something happens. But I just kind of love the idea of he's collecting all these pieces across various science films, finding all the pieces that sort of match together content-wise, and then showing them as a collection, which I think is really fascinating. I love that. We make the connection of in a filmic tradition of a dog or a wolf, and then a full moon, that sort of thing. Anyway, definitely worth a watch because it is using found footage in a really fascinating way, I think. The other thing I want to talk about this week is fan cams. I think like this is we're going from like the very highbrow experimental film to, I don't want to call this a lowbrow because it's not, but it's like very pop culturally. So fan cams I think sort of began as especially within K-pop, it was a way to follow each individual star. So everyone would make their own, whoever was their favorite person in the group. They would just sort of like either follow them around manually with a camera or edit a sequence so it was only them. And this has kind of developed into this whole like ecosystem. You can go online and like go into YouTube and watch people say how to make a fan cam. And I think we could actually do some of this both today and even next week when we start to do body detection, to actually track our favorite person in a piece. I kind of love this idea. We've now gotten to the point where I found this last night. This is a fan edit of K-pop stars watching fan edits, which is just like folding in on itself in a very, very fascinating, funny way. And obviously this is also expanded outside of K-pop. So I saw this recently where I guess it's pretty common actually that people have started making celebrity fan cams. So when someone says, "Oh, I think Adam Driver's ugly," one of Adam Driver's fans will post this fan edit of just him, looking attractive or being a good actor. I guess I don't know. It's fan culture is a very weird world, and I won't even try to begin to explain it. But I think there's just something very, very interesting about how we've started to make all these edits, and because editing tools are very easily accessible, people who have a particular obsession can spend time making these things. And I think this is definitely something we'll look at this week. Like I'm going to do the same thing with like an X-Files clip, and only pull out the one actor or whatever from it. So very cool. But I actually think the funniest thing is that one of the earliest American experimental films, I would argue, was actually also the first fan cam that was ever made. So in 1936, Joseph Cornell, who's usually known as like a collage artist, he would make these very intricate collage boxes, a very famous artist. He made a film called Rose Hobart. And this was, he bought a 16 millimeter film, and he became obsessed with the actress Rose Hobart. So he cut up this film and only showed the parts that were of this particular actress. So he spent a couple years editing this together to only focus on her. He apparently made a bunch of different cuts that would then include other parts like outdoor scenes or other things. And then he finally showed this at MoMA, I think, I don't know, like late 30s, early 40s. And a sort of apocryphal story is that Salvador Dali was in the audience. And when he saw this film, he freaked out and he pushed the projector on the ground and started screaming that Joseph Cornell had stolen this idea from his brain, that he had the same idea to do this, and someone would have paid him to make it and whatever. He freaked out. And Cornell, who was like kind of notoriously a recluse, chose to never show this film again, or it took him 10 or 15 years before he would show this film publicly again. So just some really fascinating history, and I would also argue like a very, very early version of a fan cam, which I kind of love. So I love that this is also, we're talking about pop culture, but it has its roots even in the experimental avant-garde. So there's some sort of inspiration for you for this week. All right, so as a reminder, when we talk about content analysis, the biggest challenge for us, we saw it last week, we're going to see it again this week, is do we want to work at the clip level or do we want to work at the frame level? And the reality is that most of our tools are not really that well set up to do video. They're computationally inefficient. There aren't a good amount of data sets, and we'll talk about data sets in a minute. But really, like a lot of times we have to operate on the frame level. And one of the challenges when we talk about operating at the frame level, especially as we try to describe motion or describe things that are happening in a video clip, is how many frames, how often are we actually looking at those frames? And you might say, well, like, let's just start by taking every frame. So we take every frame and we process it using these models that we're going to look at. We're going to do a lot of machine learning models this week. We would process those and then we would look at, that difference. So let's imagine, say that this is a camera motion that pans from one character to the next, maybe even from one animal to the next. Like let's say it starts on this a home video and it starts on your dog and then it pans over to your cat. if I were to take every single frame, I would get all of the content from that. The problem is that you're doing a lot of computation for a lot of frames where there isn't a lot of change. Remember 24, 30, 60 frames per second means from frame to frame there's going to be very little change because our eyes need to sort of think that it's the same. It's like fluid. It's not changing very often. So this is actually going to be very expensive. And we saw this actually with k-means, right? When we tried to process every frame individually, it was quite the expensive process. And it would be, it took a lot of time, essentially. It took a lot of time. So in general, it's a bad idea to grab every single frame and try to process them. Now you might then say, well, like, why don't we go to the opposite side of that and only pick the first frame or only pick the last frame? Well, if you remember that we're doing that panning process, we're going from, our dog to our cat. The first frame is going to be a dog. The last frame is going to be our cat. And if we only pick the first frame, then we only get our dog. So this is kind of a challenge, is we wouldn't actually get all the content we want to capture using that technique. The other thing I'll mention is, with Piscine Detect, we saw there's some glitchiness there, right? With a tool like Piscine Detect, sometimes that very first frame is actually from the previous clip. So we want to make sure we're definitely not pulling the first frame by itself ever. So where we end up kind of landing, and this is what we'll see throughout the rest of the tutorials this week, is maybe the best, or like maybe the middle ground, not too hot, not too cold, just right, is to actually grab sort of a sequence every couple frames. So maybe instead of 24 frames per second, we grab it at 1 frame a second, or we grab it at 2 frames a second, or maybe even 1 frame every 2 seconds. And the reason this is good is that it's efficient, right? It covers, it takes a lot less time to process that. It covers all of the clip content. So let's say we were actually panning from dog to cat, but in the middle was our child. We wanted to capture all those, and this process would, depending on how fast we're panning, would likely capture everything. And here's where it becomes how frequent, right? If you know there's a lot of flashing in your pieces, or it is some experimental thing where there's sort of like, fading in and out between various pieces of content, you want to make sure you try to match up that. And that's where the challenge will be. I think in general, 1 frame a second is probably a good sort of just like baseline to sort of work with. Things don't happen to move that quickly, and if they are, they tend to be blurry. So in general, this is probably a good rate. But we're going to look at this and do this a lot during our tutorials. So if you have a lot of video clips, you will likely be spending a lot of time this week just processing every other frame. And every notebook will include a tool to do that, but it takes time. I think when I was doing a feature-length film that was like 90 minutes, it took about an hour and a half to get out every other frame, 1 frame per second or whatever. So it's not a fast process. Just be aware of that. Cool. So now let's talk a little bit data sets, because we're going to talk a lot about machine learning this week. Almost, I think everything we're going to look at is machine learning based, except the color stuff, but that's a whole different from last week. So everything we're going to look at this week is machine learning models. And machine learning models use data sets. And we're going to be looking at classifiers mostly, and I'll talk a little bit more about that. But the key for a classifier sort of data set is actually that they're images and they're paired with a label that describes, using one label, what is in the image. So an example of a classifier data set, I've got a link to a bunch of these, is this one, which is called ImageNet. One of the most common image data sets you're going to find. If you just Google image data sets, you'll basically find MNIST, which is a handwriting model, and you'll find ImageNet, which is this model. ImageNet is 1,000 different classes, and it is both animals and objects. I don't know why they chose animals and objects. Those are just what they chose. And they chose a bald eagle, of the 1,000 classes, there are probably hundreds of images of bald eagles and hundreds of images of teapots, and then there's hundreds of images of toilet paper, hundreds of images of dogs, and 100 images of cats, that sort of thing. So here are a list of some of the more popular classifier data sets. You would click on the links and go and actually look at the data sets and go and look at the labels for them. Actually, that's probably a really popular or like good idea to do. So for example, we've just looked at ImageNet. We just looked at MNIST. We'll look at MNIST. MNIST is a model of handwriting. So you'll see here that there are a bunch of handwriting numbers. It's always numbers. So it's, people writing weird looking 5s or weird looking 7s, and the model being able to learn that. If you do any like machine learning 101 class, you will probably be forced to do something with MNIST. It's really boring. I don't find a lot of use in it, but it's a good example of how to train a model to learn how to detect handwriting or read handwriting, essentially. There's a ton of these models. Coco happens to be for object detection. We'll talk about that in a minute. Scifar 10 and Scifar 100 are also very popular. If you click on this link, you'll see, here's the images. So a Scifar 10 dataset contains 6,032 by 32 color images with 10 classes. And classes, remember, are the labels. So I believe Scifar 10 includes, here we go. So it's airplane, automobile, bird, cat, deer, dog, frog, horse, ship, and truck. So these are the labels. Now, why did they decide these 10 labels? I don't really know. I would guess because it's like a mix of animals and objects that are different enough that it's a good representation of the overall data set. But the important thing to know is that in these models, it is only these labels. So there is no like brown horse, black horse. It is horse. That's it. And that'll become a thing we kind of see as like kind of a limit of these tools. Likewise, there is LSUN, which is, I believe, a bunch of like, there's an LSUN cars and LSUN bedrooms and LSUN churches. LSUN, I believe, is a university. There's just a bunch of these. There's also a flower model. There's many, many, many more. And if you just like look on this site, which is called Papers with Code, you'll see that even within image classification, there are a number of data sets. So Papers with Code has 225 different data sets. And as you begin to think about what you want to achieve with your video project, you may want to come in here and look at these data sets to see if there is something that could do what you want it to do, because we will look at training a custom data set this week, but they'll be basic, very basic, like 2 or 3 labels and not 100. You may find that one of these models or one of these data sets is actually really good for what you're trying to achieve, and then we just need to find a model that uses it or train our own. There is also the site called Hugging Face, which we'll talk a lot about this week because it tends to be where a lot of our models and data sets come from. And here are 381 data sets around image classification. So there are a ton of different, you'll see MNIST is there, Scifar 10 is there, Oxford Pets. So there are a lot of different data sets here. And again, we'll only look at 3 or 4 this week. But you may find that one of these actually works better for you, or it does something interesting for you that you want to work with. If that's the case, feel free to DM me, and we can talk about whether you can train your own model using these data sets, whether something out there exists already that's called pre-trained, or that sort of thing. So in general, like, it's good to start with what's out there and see if you can find something that is already working off the shelf for you. And then from there, it's like you can possibly train your own, but it might be a pain in the ass. In fact, it's usually a pain in the ass. So that's data sets. I just want to talk a little bit about that because it'll make a little more sense when we get into the tutorials on this. So data sets lead to a thing we call models, and you'll hear me talk quite often about models. Now, what is a model? A model is a machine learning set of code that someone has taken and paired it with a data set to create a task. So models are solving different tasks, right? So in our case, we're going to look at our image classification. That will be a big class of different tasks we're going to look at, and different models will do that. Now, a model is often trained on an individual data set. So we will say, is there an image classification model that has been trained on Scifar 100 or Scifar 10? Is there an image classification model that has been trained on ImageNet? There are many of them, but this particular one. Now, the key to a model is that it is both so basically when we talk about training a model, that is when we take our data set and we run it through what's called a network to train our model. And in this model, usually we have to feed it a specific item. So in our case, for a lot of our image classes, we're going to take our 1,000 images of frogs, 1,000 images of deer, and we're going to feed it in through the model and say, your goal is to figure out how to differentiate frogs from deer so that you can make a model that does that. So this is the training process. Most of what we're going to look at in this week is what's called pre-trained, meaning someone at Google or someone at a lab somewhere has actually already trained this model, because sometimes training these models takes a lot of money and a lot of time. So someone will have already made an image classification model on ImageNet that we can then use. Now that's different from inference, which is really what we're going to be doing mostly this week. In inference, what we do is we feed the model an image, and it says, oh, I know what that is. That is a deer, or that is a frog. Or in the case for a lot of what we're going to do this week is that's a dog versus that's a cat. So the important thing is that these models have been trained on a data set, and that data set, the training, what it knows and what it doesn't know is actually going to affect what our outputs are. So if this data set only includes deer and frogs, then the model only understands how to classify based on deer and frogs, which means if I try to feed this model an image of a cat, it's going to say that's either a deer or a frog, and I can guess that it's maybe a deer because it's fluffy or furry or something. So this is the key thing to know, is that the task that you're requiring the model to do needs to match up with the task it already knows how to do. And this will be one of the challenges for us, is that a lot of models out there don't actually do what we want them to do, and we're going to need to either train our own or find something that's an approximation of what we're looking for. So there are a number of different model task types that you will often see, and we'll look at two of them this week. The one we'll look at is a classification model, and then we'll also look at a detection model. And you can kind of get a sense here of how they work. So classify models give you essentially like a label. They say, oh, there's a person, there's a tripod, there's a safety vest in this image. Detection models give you like what's in the image, but also where it is in the image. Segmentation models, which we won't really cover in this class because I don't know, there's not a whole lot of usage for them, and when I use them, they're kind of crappy. Will actually give you the like outlines of where the segment is. So detection only gives you a bounding box. Segment will give you like the actual pixel values of that. I think we'll look at tracking and pose detection next week. We'll definitely look at pose detection. I'm thinking we might cover a little bit on tracking as well. So this is just a segment of machine learning models that can help us define what's in an image or what's in a video. Let's talk about classifiers, because that's mostly what we're going to look at this week, and that's what we started looking at last week, right? Oh my God, bug, damn. Okay. So as you recall, last week we looked at a shot type classifier, and that classifier told us, like, you fed in a video and it guessed, what the shot type was. Wasn't super accurate, but it was close enough, and it would try to define like what the shot type was. So it was only able to define a shot type, and that's what a classifier does. There are a couple different types of classifiers, and by that I mean like there are ones that are trained on large label data sets. So something like ImageNet, which has 1,000 categories. That's a lot of labels. That's a lot of categories. That might cover all of your needs with that one model. So the upside of that is it's very flexible, right? If you're trying to go through a ton of nature footage and you want to categorize it by, is there a deer in the scene? Is there a frog in the scene? Is there a bald eagle in the scene? Then a model like ImageNet would be great for that. It's very flexible. The downside of this is, and we'll definitely see this with ImageNet this week, is its performance is often not great. Because it's trying to choose between 1,000 categories, that's a lot of decisions to have to make. And therefore, it often is like slightly off. Like when we look at like trying to figure out if a dog is in the image, it will often guess the wrong type of dog. It'll know it's a dog, but it'll guess the wrong type of dog. And that makes it kind of annoying for us. And usually that means you have to like kind of work around the model a little bit. And you might say like, okay, even if it gives me like a Yorkie, that means it's a dog. So let me just kind of group those together into a bunch of labels as a dog set of labels. So they're not always the most accurate, which is going to be a challenge for us. On the flip side, you have small label data sets. Now, these are models where maybe someone's trained like, anything. It could be soccer versus baseball, or in our case, dogs versus cats, or, maybe the 5 K-pop stars that you most like. So can it figure out who is who? And then the nice thing about this is that they tend to perform better, right? If you give it those labels, and they're a small enough set, they will do a good job of actually finding those. The downside of that is that that's a very unique niche task, which means it won't generalize to a bunch of other things. So if I'm looking for a bunch of K-pop stars, and then someone says, hey, can you do that same project but for a bunch of rappers, you're gonna have to go train a separate model. And training models these days doesn't take very long, but it's still like annoying. You're gonna be like, oh, I can't just use that here. The other thing I want to mention is if you create like we mentioned with deers and frogs, then if you have a model that only knows how to assign a label of deer or frog, any image you provide it is going to only get an answer of deer or frog. So if I start to send it K-pop stars, it's going to say, that's a frog, that's a deer. Hopefully it would say it's I don't even know which one it picked, but hopefully one changed its mind between those. But anyway, it's only going to provide those labels. And as we'll see, anything that's out of that scope is going to get glommed in with those labels, and we're going to have to figure that out. So again, if you've got a bunch of nature footage and the majority of your images are bears and bald eagles, and you train a model on that, but you've got a couple frogs and a couple, deer, they're going to get put in one of those categories regardless. And that can lead to some challenges for us, and we'll look at some ways around that this week as well. One of the first ways to look around that is what's called a confidence score. Now, this is like a thing that I think is really, really important to understand about machine learning. Machine learning does not give you a answer, it gives you a probability. And this is one of the things I think is often either misconstrued by people who are anti-machine learning, and often, I should also add, is hidden by people who are pro-machine learning or people who are building tools. I actually think showing the confidence score is very important to understanding what these machine learning models are actually doing. A confidence score is, when I send an image to one of these machine learning models, it is not just saying that I think this is a dog or I think this is a cat. It's saying I think with a high probability this is a dog, or with a high probability this is a cat, or with a low probability it's a dog. And those confidence scores should actually matter a lot to you, because that might mean that there's something that is slightly off with that image, or it's actually unsure of how to classify that image, and therefore you should keep an eye on that. So an example here, so often it's also, we'll talk about this in a second, I'll come back to this one actually. So here's the thing that actually really happens generally is you might open up, some sort of machine learning app on your phone, and you're going to feed it images and it's going to start labeling all of them. Now, if it's a good one, I would say it should include a confidence score. If it's a bad one, it's probably just, going to hide that. So you might look at an image like this, and the machine learning model would say, that's clearly a dog, and I have a 93% confidence that that is a dog. You might then feed the model an image like this, and it's going to say it's a cat. And you're going to say, well, why does it know it's a cat? Yes, there's a cat there, but there's also a dog there. Why did it choose a cat? And the key here is that the confidence score will likely be lower. The confidence score might be something like 52%. And you'll say, oh, well, what's the 48%? And the 48% might be the dog, right? So this is kind of the key with confidence scores, is that it indicates something about either the image or how the model has been trained, or just what it knows. And the key thing to remember here is, I'm sort of making up a model that only trains dogs versus cats. But confidence scores are also based on the number of labels possible. So a 50% confidence score with a 2 label option, say deers versus frogs, is bad, because that basically means it thinks it's like a coin flip. Because you could basically flip a coin and choose between one of those two categories, and that's your probability that is one of those. Let's say you've got 1,000 labels, like in ImageNet. 1,000, a confidence score of 50% with 1,000 labels is actually very, very good, because there's probably a long tail of probabilities of it being something else further down that label classification. So in the case of something like dogs, you'll often see dogs, all of the dog labels, all the different types of dogs, generally show some high level of confidence. So it might be I think this is a Yorkie with 30% confidence, and then I think it's a pug with 5% confidence. And that's because it sort of knows that dogs are related to each other. But it's never going to give you a full 100% confidence, usually with 1,000 label data set. So we'll see confidence scores quite a lot in this. I should also mention I'm making up that sort of 50%. Each model kind of does their own way of scoring things, and we kind of have to figure out what high and low is within those models. But essentially the idea is confidence scores are actually really, really, really important. And I hate when people show machine learning demos without showing the confidence scores, and they say, look how bad this thing is, it's clearly biased. I'm not going to say bias doesn't exist with a machine learning model, but what I am saying is if you don't show the confidence score, you're not really showing how the model is actually acting or thinking as it goes through that. And sorry, acting and thinking makes it sound like it's intelligent. It's more just the model's been trained to think about probabilities, and those probabilities are important to the output of the model. Okay, so that's a little bit about classifiers. We'll look at a lot of classifiers in this week. We will also look at one object detection model. And I think object detection models are very interesting, especially for what we're trying to do, and here's why. Object detection models provide classes, confidence scores, and a bounding box for the objects that exist within an image. And the key here is that multiple objects can exist within one image. So in most classifier models, you can only ever have one label per image. There are some other ones that do stuff outside that, but they're generally not very good. So in most cases, a classifier model will only give you one image and one label. Now these, if you look at some of the outputs from these, you can generate these fairly easily, but often what they're going to do is they're going to give you a class and a bounding box and a confidence score. Now the confidence score isn't shown here, but it would exist in the model. In this case, you'll see it's a car, a bicycle, and a dog. And the important thing for us in this class is less the bounding boxes and more like the actual labels. Now I know in this frame there is a car, a bicycle, and a dog. And that's important because another classifier model might only tell me there's a bicycle or only tell me there's a dog. And I would miss out on the other elements in this image. So we go back to our dog and cat problem. The good news is that an object detector would actually tell us there is both a dog and a cat in this model, or in this image. And it would tell us, I am 91% confident there's a dog here, or I'm 82% confident there's a cat here. And that's really important to us because that tells us about more what's in the scene than less like what this scene's classified as. So we'll look at this, and this will become kind of like, I don't want to call it the most important model, but it's actually very, very helpful for us to use. The other model we'll look at in this class toward the end of our tutorial series is captioning models. This is kind of a newer type of model. Classifiers and object detectors have existed for almost a decade now. Captioning models are kind of new because it turns out creating captions is kind of hard. This newer model, you feed it an image or you feed it a video, and it actually returns what the entire sort of like what's happening in the scene, but from like a in a text-based format. So whereas this is just purely like, hey, at coordinate 50 through 75 is a cat, and then this one is a dog. These captioning models will actually say, in this picture, there's a white background with a gray kitten and a white puppy dog with yellow ears. Now that's the goal. I'm going to tell you, to be honest, like a lot of these captioning models tend to be hit or miss. They often get like the basics right. Like they'll tell you like there's a dog and there's a cat on a white background, that sort of thing. But they often, like, if you play with ChatGPT or any other like large language model before, they kind of like make up little stuff. Like they make up the details that make it sound realistic, but then when you look at the image or look into stuff, you're like, man, that's lying. It's making stuff up. That will happen with these models as well. And that's really important to be aware of because it means that when we actually try to like judge the truthiness of these captions, we have to kind of judge on a curve. The other thing that will often happen here is you're going to see a lot of biases. Now we've talked about biases. I don't want to even, they're definitely in every model, but I would say biases are especially problematic in large language models, of which captioning models are kind of a part of that. The thing here is that, white men in suits will be policemen or sheriffs, and black men in t-shirts will be drug dealers or something. I might be extending that and making that a little bit hyperbolic, but it is kind of a thing that happens, and I'm sure you've seen many examples of this on social media or through articles talking about machine learning and bias. It is definitely a problem, and it's likely a problem that at least one of us will come up with in this class. And I want to show how we use these tools because I think it's important to see how we use these tools, but I also don't want to hide the fact that they will probably be biased. So it's important to be vigilant about what your outputs are and think about how you're using it, right? So, I guess on some level you could maybe say like, here's a bunch of biased clips of how it portrays black people. If you do it as an angle of like, I want to portray or I want to highlight how these models are bad, that seems good to me. But if you're kind of making up a script and like you want to pull from random clips and one of your people is a gangster or something, kind of be careful if you're saying it's a gangster and they pull in a black character or a video clip of a black person, and that's not what you intend, or like that's like kind of a bias within these tools. So think about that as we go through this. Again, we'll see some what I would call lighthearted bias or just like it making shit up. But there's a very high likelihood we'll also see some stuff where you're like, kind of feel a little icky. You'll kind of feel like, ooh, I don't know how comfortable I am with that. And that's okay. I want us to like fully feel that and understand that. But just be aware it's a thing that will happen with these models. Okay, I think that's everything I want to cover for lectures because the honest answer is you're going to learn so much of this by actually looking at the tutorials and going through them one by one. So I did make a color sorting tutorial. I promised I would do that. It's, I'll admit, kind of a bit of a punt, but it gives you a little bit. And then we're going to go through a ton of different models. I'll focus a little bit on doing dogs versus cats because it's a thing that already exists out there. We will look at training a custom image classifier, which I think will actually be kind of fun. I'm kind of excited to see what people create as custom classifiers. I used to think that that was kind of a hard task to do, because I've done a lot of machine learning training in my past, more for generative models. But an image classifier today takes about 30 minutes. It's crazy how fast and how good they are. We'll look at labeling actions. We'll look at using object detection, and we'll look at generating some captions. And I also included a little video. All of these notebooks will also now, at the end of them, or most of them, have a way to do EDL experts. Now, Sean Hannon in our Slack channel made some code that will actually generate an EDL export. So for those of you that are looking to do more production level kind of stuff, definitely watch that video because I think it'll be helpful. But I think there's a ton of material this week. I want to shut up and let you jump in and start exploring them. Homework for this week is, as always, add your video data set. I bet as you start to play with these models, you're going to get ideas to be like, oh, I bet I could find more videos that do X, Y, or Z, so I can classify them all the same way. So always feel free to add your data set. Now, your drive folder is probably getting very big at this point. If you have a limited drive folder size, then be a little bit wary of that, especially as we begin to make frames and things from things. Lastly, obviously, just have fun with these tools. Play with them. I'm really excited to see what people make with them. I think there's some really fun things that can be done with this. I think, especially in the context of this class of taking found footage and running them through different models and then recreating different things from it, I think it's an underexplored area, and I'm really excited to sort of see what people make with this. So with that, I hope you have a lot of fun this week. There's a lot of material, so I understand if it's overwhelming. Take it 1 week at a time, and hopefully we're going to have a little break in the next couple weeks anyway, so you can catch up as you need it. So with that, let's jump into the tutorials and start classifying some of our video data sets.